All right, so part C is just asking for g prime of 2. And we should have already established that g prime is equal to f. So all this is asking for is, what is f of 2? So I go to 2, I see that my f of 2 is 1. 1's my answer. Okay, that's just testing whether or not you know the vocabulary.
So why is g prime of 2 equal to f prime of 2?
Because g is equal to this. So if I take the derivative of both sides, I want the derivative. Okay? And we just learned that when I take the derivative of that, it requires what? What am I using to take the derivative of that? Let's go.
FTC.
The second FTC. Which just tells me all I've got to do is plug in my variable. So we know that g prime is equal to f. What else? Raise your hand, please. Yes. All right, find g of 0, g of 3, g of negative 2, g of 5. So g of 0 is easy. I plug 0 in. We're going from 0 to 0, which is 0. Plug in 3, 0 to 3. So I just need my area from 0 to 3. So I've got a quarter circle. A quarter circle is 1/4 pi times r squared. What is r? 2. So that makes 2 squared. And then plus this little triangle is negative 1/2. Okay, so we end up with pi minus 1/2. Plug in negative 2. What's the issue when I plug in negative 2? It's backwards. So since it's backwards, that means I have to take what I get over there and then do what with it? Make it negative. So this right here, I just figured out, is pi, since I'm going backwards, negative pi. Plug in 5. So we're going from 0 to 5. If you notice, this triangle and this triangle do what to each other? Cancel each other out. So all I need is 0 to 3, which I just found out when I found g3. So that means g of 5 is equal to pi minus 1/2 as well. What else? Hey, Courtney. Hunter?
3C.
All right, 3C. On what intervals is G concave down? Now, what we should already establish somewhere in here, if we haven't, yeah, we had to do it on part A. We need to establish that G prime is equal to F. Okay, so I'm looking at the derivative of G. So how do I use the derivative of G to determine whether or not G is concave down? Raise your hand, please. Elias. If it's decreasing. So I need to know where is that decreasing. So we're going to decrease from here to there. Now these aren't exact, so I'm not going to spend all day figuring out those numbers. This right here, I'm going to call this 1/2. That right there, I called it 1.75. So 0.5 to 1.75 on the first one. And then from here, I called that 3.25. Again, if you got close, I'm happy with it. And then this graph only shows me to 5, so that means I have to stop at 5. Okay? Haley, what's my justification on that?
Because f is decreasing.
Because f is decreasing. Good. Very good. Hunter?
So on A, for one of the intervals, I put 4 to infinity because I saw that there's an arrow. But do you just
No,
put?
you can only talk about what you see. You only see the 5, so it needs to be 4 to 5.
Right. Or like when you're looking, so where the graph of f is basically g prime, correct?
It's not basically, it
It
is.
is. Okay. And so when you're looking for a concave down, isn't it once you're supposed to decide if the derivative is negative, then that tells you if you're. I thought concave down you have to be decreasing in the first in the f or g.
All right, let's make our chart again since it's been a while. All right, so we'll start here. My derivative. If my derivative is positive, what does that tell me about f? Increasing. If my derivative is negative, what does that tell me about f? Decreasing. And then we come over here. If the second derivative is positive, that means the first derivative is increasing. And it means the original function is concave up. If the second derivative is negative, that means the first derivative is decreasing. And that means the original function is concave down. So, what do we have to work with here? What were we given? We were given that. So if I'm going to determine concavity is right here. I'm given the first derivative, so that means I need to be looking for increasing or decreasing. Make sense?
Yeah.
I don't believe you.
That's fine. I don't know how I'm thinking about it, but
Well, we've got to go back to this. Okay? A lot of people in the past, whenever they get to a test, this is one of the first things they write down. And then when they get to a problem like this, then they go to it. Again, what am I given? What am I given? So I identify that, and then what do I want to prove? I identify that. Where those two things meet, that's what I've got to be thinking about. That's how you use this. Got it? So if I was given the second derivative and I want to talk about concavity, then I'm going to go second derivative, I'm going to go concavity. I need to be looking for positives and negatives. Okay? Up here, we want it to be decreasing. Okay? Here's decreasing. I was given this, so I need to be thinking about that. That's how it works. What else? Courtney? Question? Yes.
So on 3A, you're looking for where the graph changes from positive to negative?
Not changing because I want to know where it's decreasing. So decreasing means I'm looking for
Just where it's negative.
when it's negative. So I'm looking at that section and that section. Again, if you don't have all that memorized, this is something that is extremely helpful.
I'm gonna get tattooed on my hand.
No. Any other questions?
Well, listen, what if I do get tattooed on my hand? And I got the trig function tattooed on my
They
hand?
probably make you cover it up.
How? I'm gonna claim the discrimination, not how, but like, I'm gonna claim that there's discriminating against my body.
No. Anything else?
Like
Put the unit separate
Okay.
on my palm.